Hello. Good morning. Welcome to the first session of day one after keynote. We had an awesome keynote today. In this session, I'm going to talk about how to set up a secured and scalable notebook for Spark running in a Hadoop cluster, and most importantly, in a corporate environment. My name is CHAKRABORTY. For the last 17 years, I design and write software for a living. I currently work in Bloomberg in the data platform team as a distributed system architect. This is our little agenda for today. We'll first set the context about why we need a notebook for data science activities. Then we'll talk about some of the design and the technological considerations. We'll then give a deep dive into the integration and the implementation part, followed by a Q&A. So let's have a look on why we need a notebook in the first place for data science activities, and what are the motivation behind it. A couple of years back in Bloomberg, there was an initiative in the data platform team, and it was to create an infrastructure which can ingest and store the data at its lowest level, basically to create a data lake to capture as much as data as possible. And the second part of it is to provide a tooling across the organization to access the data for various purposes, such as data exploration, analysis, doing machine learning activities. Most importantly, to provide a better service and develop better product for our customers. But the most important thing for the organization was not just to do these activities, but to do it consistently, reliably, and securely across the entire organization. Security, and specifically Kerberos in the context of this presentation, is the utmost important requirement for our organization. Now, if I like to put all these requirements at an abstract in a pictorial view, it looks something like where the data is coming from various sources. It could be within the organization, outside the organization. Then it gets ingested in a distributed storage environment. And then finally, you need to process and access for various purposes and needs. But in this part of the presentation, I will talk on how to provide a consistent and secure tooling to access and process the data in a cluster using Spark. The reason I'm going to talk about Spark, because Spark is one of the major distributed processing framework in Bloomberg, as well as I believe in many other organizations. Now, before we look into the tooling part, let us look into the organizational requirement for tooling. While working on this topic, specifically this project, and doing product evaluation on available products in the market, it was evident that the required tool needs to be, first of all, very easy to use, customizable, it should be extensible. It can be used by data scientists who having strong programming background, as well as those people or those folks who doesn't have strong programming background, may be familiar with a skill like SQL. Now, these are not the requirement which is specific to just our organization in Bloomberg, but it's very common across the industry in these days. So we decided to use Jupyter Notebook as our client-side tooling to perform the data science activities for various purposes. Now, let's have a look what is a Jupyter Notebook for Spark or Spark Notebook. I'm going to use these two terms interchangeably during this presentation. Now, a couple of features of Jupyter Notebook. It's a web-based, which means you can access it from anywhere, and easy to deploy. It supports multiple programming languages like Scala, Python, R. It provides a templating, which means you can start with some templates that has been provided by the infrastructure. It provides multiple extensibility points, and some of them we are going to touch today, like a security extensibility point, login extensibility point. Now, the kind of activities you can do through Jupyter Notebook is it's interactive. You can do data discovery. We have seen in the keynote presentations, specifically in the IBM part, that some of the notebook features that they have added in their own notebook. You can also perform programming and SQL kind of activities inside the notebook. Now, if I have to put up a stack for a Jupyter Notebook in its plain vanilla form, you may find that it doesn't do much actually with Spark. Also, since Jupyter is a web application, you have to remember that it has to submit the Spark job over web using HTTP, which is different than submitting a traditional Spark submit, which is in a shell-based environment. So in order to make it work, I'm going to introduce a few more components. So we'll start with something called Jupyter Hub. Now, Jupyter Hub is actually an extension of Jupyter. It supports a multi-user environment for Jupyter Notebook, which means through Jupyter Hub, you can manage and maintain sessions for multiple users and store their information. The second project that I'm going to introduce is called Spark Magic. Now, Spark Magic is an open source Spark kernel, which is made for many languages like Python, Scala, and they also started supporting R recently. Now, the kernel in a Jupyter Notebook is one of the extensibility point where you can basically plug your own kernel, and that's the good part of the Jupyter Notebook. Then the second project that I'm going to talk about is Livy. Now, Livy is another open source project which basically runs a HTTP REST-based web service, and you can submit your Spark job over HTTP. And once you submit, Livy should be able to create and manage the Spark sessions and should be able to run it, the job in the cluster on behalf of the end user. And then finally, we have HDFS and Yarn, which I'm not going to talk a lot in this particular presentation, but of course, the Spark is finally running in a Yarn, and the data is stored in HDFS. So let's have a look. When we run Jupyter Hub, Spark Magic, and Livy in its current state, which is available today. A user opens up his or her favorite browser and accesses the Jupyter URL. The browser is going to send the request to the Jupyter Hub. The Jupyter Hub is going to forward the request to the Spark Magic kernel. Spark Magic's responsibility is to create a HTTP request, submit it to Livy. Livy is going to take the HTTP request, create a Spark job, submit it to the Spark cluster. Cluster is going to run the job, return the output back to Livy. Livy is going to create the HTTP response, send it back to the Spark Magic, which will forward the response back to Jupyter Hub, which is going to render back to the browser. So this is the current state of workflow that you can have. The last but not least, Jupyter Hub, as I mentioned before, is a multi-user environment which supports separate process for each user to isolate between different users' activities from each other, which is important when you are going to run a scalable model so that one user's activity should not impact other user process. Now, this looks fine, but one of our main organizational requirement was to support Kerberos because it is an organizational standard for many other existing systems. Now, just to give a little information about Kerberos, it's a very widely used authentication protocol across the industry. It is different in a way than a lot of other authentication mechanism is. You only need the user ID and the password for the very first time while you getting authenticated across the chain of services. Once you are authenticated, you get a ticket, and then you are basically going to use the ticket for the rest of the service-to-service communication. Now, very commonly, Kerberos uses various account databases to pull the account information for the users, such as Domains Active Directory service. Now, what we are going to look is, if I introduce Kerberos in our current Jupyter Spark notebook stack, what we have just seen, how it looks like. Today, we have HDFS that supports Kerberos. We also have Livy that does support Kerberos too. One thing to highlight, because it's going to be very important for the rest of the presentation, is the concept of proxy users supported by Hadoop services, which is not something new. Proxy user allows a super user to impersonate a regular user in HDFS or any other Hadoop services like Hive or if you run Uzi, as long as the respective user is part of a super user group defined in the Hadoop configuration. The way you specified this configuration is in the core site.xml file in the Hadoop deployment. And there is a little config snippet that shows how a Livy user can take advantage of the proxy user concept and impersonate a regular user in order to submit a Spark job to the Yarn cluster. But the unfortunate part of this whole story is Jupyter Hub and Spark Magic doesn't support Kerberos. So the rest of the presentation is to show the changes that's required to enable Kerberos for Jupyter Hub and Livy. Before we go into the details of the changes in Jupyter Hub and Spark Magic, let's see how Kerberos works in HDFS and Spark running in a Yarn cluster so that we are all on the same page. This is kind of a brief introduction of Kerberos. We have three components. We have a client, which is considered as a traditional client. We have a HDFS cluster, which is running various Hadoop services. And we have a KDC server. KDC server, which is a Kerberos server, has two essential components. One is called authentication service. Another is called ticket granting service. During the startup, all the services in the Hadoop cluster talks to KDC and gets something called service principal and keys. These artifacts are used to authenticate any incoming request carrying a service ticket from the same KDC server, and that's how it actually authenticates the client. Now, the way it's going to work is the client goes to KDC first with its user ID and the password. It will be authenticated. Then it is going to get a ticket, which is called TGT ticket. That ticket, then the client is going to take, and it will go to the ticket granting service and tell that, hey, I need a ticket for HDFS, or maybe I need a ticket for Hive, for different Hadoop services. Once it gets back the ticket, then it is going to use that ticket to communicate to the clusters. Then the cluster is going to use the service principal and the key to authenticate the client, and at the same time, it's going to retrieve the user permissions from the account database. And now the connection between the client and server has been established. And this is how Kerberos works in HDFS, Yarn, or any other services that supports Kerberos. Now let's have Jupyter Hub as a client instead of a traditional client, and bring Spark Magic and Livy into the picture and see what are the changes required. Now, this is where we left a couple of slides back. The first thing I did is to change the traditional client to a browser, because Jupyter Hub is a web-based application. And that changes the communication pattern between the client and the Hadoop cluster. So I took away those communication links. Some of the other communication link also I took away, because now the communication between the browser and the KDC is going to be different, because now my client is a web client. Now let's introduce the Jupyter Hub and Livy. You will notice that once I introduce the Jupyter Hub, there are two new components that you see besides Spark Magic. One is called KDC Authenticator. The second one is called a Docker Spawner. Now, KDC Authenticator is a component that has been developed in our organization using the extensibility point that is supported by Jupyter Hub. Jupyter Hub has an extensibility for authentication. So I can plug in any authentication type that I need. I can do an OAuth authentication. So we developed something called a KDC Authenticator, which basically will authenticate using Kerberos. Then the second component is the spawner. Now, the spawner in Jupyter Hub is another extensibility point for per user notebook session. Since Jupyter Hub is a multi-user environment, here we are using a Docker spawner for Docker to create a separate Docker container per user. What does that mean? That every time a user is going to authenticate, then it is going to create a separate container per user so that there is an isolation, which I talked before. So this is why I'm using over here the Docker spawner. You can use any other kind of a spawner. You can create just a spawner to create separate process per user. Because the Jupyter Hub provides the extensibility point for the spawner, that's why I'm able to create my own spawner. Now let's explore the new communication bridge between the browser to Jupyter Hub and then Spark Magic to Livy. The difference is now we have more authentication points which you can see. And because browser needs to authenticate against Jupyter Hub and Spark Magic needs to authenticate against Livy, and all of these have to work with Kerberos seamlessly. One of the other point that I would like to highlight now, because Jupyter Hub and the Levy, they are running in a different nodes, so I can actually scale them independently. For example, if I need to support multiple Hadoop clusters to run my notebook, I can actually run multiple instances of Levy, each pointing to different Hadoop clusters. Now, as HDFS as a service, what we have seen before, gets the service principal and the keys during the startup we discussed before, Levy and Jupyter Hub will also get its own service principal and keys during the startup. Now, these are HTTP service principal because the communication that they support are over HTTP. One other point, I have just moved the level descriptions to the right for presentation purpose, just for better visualization. Now, the browser gets the TGT ticket as before from the KDC authentication service. Now, the browser will communicate to the Jupyter Hub URL in a traditional web communication pattern. But since Jupyter Hub URL is set for Kerberos, what it's going to do is it's going to reply back with a 401 message, also known as authenticate negotiate for the Kerberos ticket. Now, this pattern of communication is well known in the web scenarios, also called SPNAGO, which is supported by most of the modern browsers, so you don't need to make any change. But you may need to enable for some of the browsers. Now, the browser then gets the service-specific ticket from KDC. In this case, the ticket is going to be for a Jupyter Hub service. Once it gets the ticket, it's going to send another HTTP request to the KDC authenticator. Now, the authenticator is happy because now it has the Kerberos ticket information. So, the responsibilities of KDC authenticator in this case are support SPNAGO, authenticate the user using the HTTP service principal and keys, and to retrieve the user ID once the user gets authenticated. Now, why it is retrieving the user ID, we'll see it in next few slides. Once the Jupyter Hub KDC authenticator authenticates, now the connection between the Jupyter Hub and the browser has been established. Now, the Jupyter Hub KDC authenticator is going to forward the request to the Docker spawner, which spawns a user-specific process, or in this case, a separate container per user. Now, the activities that spawner does in this use case are, it encrypts the user ID and puts into an environment variable inside that container. And it opens a new notebook sessions or a new notebook container. The reason it needs to encrypt the user ID is because of the security. What happens is the user ID can be actually modified by the respective end user because the end user has a full access to the notebook session. Even though I can give you a notebook, you can use few lines of Python code to access the environment variable and you can change it. You don't want user 1 to impersonate user 2. The encryption of the user ID before the spawner spawns the user processes to protect the authenticity of the user submitting requests to the Levis, and that's why the user ID gets encrypted before the spawner spawns the new container or the process. Then spawner is going to send the request to the Spark Magic. Now, Spark Magic needs to communicate to Levy, which means Spark Magic has to get authenticated against Levy. In order to do that, Spark Magic is now going to talk to the ticket granting service and tells, hey, I need a ticket for talking to Levy. Geddes is going to send the ticket. Now Spark Magic is going to do this kind of activities, which is it reads the encrypted environment variable, and it's going to add to the HTTP request body as a proxy user. You remember I talked about the proxy user concept? So because Spark Magic is going to create the HTTP request and submit it to Levy, so there is a body which is called proxy user. There is an element in the body called proxy user. It's going to put the encrypted user ID information inside it. Then the request goes to Levy. Now, once the request comes to Levy, now Levy has to talk to HDFS. So Levy has to also get authenticated against HDFS. So the similar way, Levy will also go to the KDC and tell HDFS that, hey, I need to run a Spark job in this HDFS cluster, so give me a ticket. So it will get the ticket. And what Livy does on top of it is it's going to now decrypt the proxy user and sets the actual user ID for the remote Spark submit. Because when the Livy is going to submit the Spark job, inside the Spark submit, there is a way you can set up the proxy user. Now, that proxy user needs to be the actual proxy user. Now, the Livy is running totally in a different environment where the end user doesn't have any control to it. It's just a service. So Livy is going to decrypt, and it's going to put the real user ID. Then Livy is going to send the request to HDFS. HDFS is going to use the Livy's authenticator ticket to authenticate, and it's going to retrieve the user information as before. Once it does, the connection between Livy and HDFS has been established. This is how the entire communication works from end to end. Maybe it looks a little complicated slide now. That's why I told that I put all the messages on the right-hand side. But let me summarize the changes that we have talked so far. First change are on the KDC authenticator. So inside the context of the Jupyter Hub, we introduce a KDC authenticator that supports Kerberos Penego authentication to support HTTP service principal and keys. Then the second part is the Docker spawner. Now, what we did is there is an open source project for Docker spawner for Jupyter Hub. We took that Docker spawner and we made some small changes. One of the changes is to encrypt the user ID so that the proxy user cannot be hijacked or can be modified, sorry, not hijacked, modified, and to put it in the environment variable before it spawns the new container. The changes that we made in the Spark magic is to do a kinit. Now, kinit is basically one of the command that in the Kerberos world you need to do in order to get a ticket from the TGT in order to authenticate against Livy. So that's the change. And then we added a section in the Spark magic so that it can take that proxy user and put it inside the HTTP request body as proxy user so that Livy can impersonate. Then finally, in the Livy, we made some changes, and the changes are support to decrypt the proxy user from the request body and add it to the Spark job request as required. Now, just to highlight, all these changes are completely configurable, which means you can enable or disable these changes through configuration. We are in a process to open source all of this, all the changes in Jupyter Hub, Spark Magic, and Livy so that you can run the Jupyter Notebook in a multi-user environment in order to perform your data science activities using Spark, which is running in a Hadoop cluster, or Spark running in any other cluster. The good news is we just open sourced the KDC authenticator a few weeks back, and the rest, the Spark Magic and the Livy changes are on their way. Now let's have a look into the deployment of Kerberos Notebook in a Docker environment. We actually use Docker everywhere. We just love it. It's a kind of wherever we can. The reason is it's very easy for software development integration pattern that people have learned over the year to have a container-based solution. In our deployment, the Jupyter Hub is running in a separate Docker container. Each of the user-specific spawn notebook process, as I mentioned before, is running in a separate Docker container, which means the Docker spawner dynamically creates notebook containers on demand and maintains. You can configure that when the user is gone, you can delete the container, or you can actually keep that container so that the next time when the user comes, it takes less time to initialize, because you can completely eliminate that part. Livy is running in a separate Docker container, and the notebook's permanent data, because every time you create a notebook, you're actually creating some physical artifact, right? Files. That file needs to be stored somewhere. So for that, all the permanent data is stored at an NFS drive, which is mounted to the different containers accordingly for their respective purpose. Now, before I'm going to end my presentation, let's have a look on some of the learnings, because I want to share some of the experiences while working on all these open source projects in a corporate environment. Some of the learnings are, when you are dealing with Kerberos, Levy, Spark Magic, or any other components, they are running in multiple nodes in a distributed fashion. It creates a corporate IT dependencies, which oftentimes delays the development process because there are protocols which have been set in different organizations in a different way. Now, in order to overcome some of these issues, you can choose a container-based development environment. In our case, it's something like a Docker. What it does is, it does a couple of things. First thing is, it allows you to create all the artifacts that I talked before on demand by yourself without being dependent on corporate IT. For example, in my laptop, I can run, using Docker, the Levy, Jupyter Hub, and a KDC server itself, so that I don't need to ask some other groups to create a Kerberos ticket on behalf of me, because sometimes it could be a pain point for you for the waiting period. So you can create your ticket on demand and everything in your laptop and do the simulations. And you can run, you can test. The other part is the networking. When you are going to use a Docker, your networking between these different components or different nodes will become much more easier, and you can actually control it. So I would definitely like to encourage everyone to use Docker for not only do the Jupyter Hub or Spark, for any type of complex integration projects with having multiple integrations and communication points. With that, I'd like to end my presentations, and I kept around 12 minutes, I believe, 12 to 13 minutes for Q&A, so I'd be more than happy to take questions from you. I hope it was useful. Thank you for coming again and joining me today, and have a good time for the rest of the conference.
Do the Docker containers run on the same host as the Jupyter Hub, or can you configure it to run like as Yarn containers? What have you guys done with that?
Okay, now in our case, the Jupyter Hub itself is running in a Docker container on a different host. Then the spawners that are getting created is actually in the same host in one of the deployment. We are actually now upgrading this whole deployment model to Kubernetes, where you can actually host all the different spawner containers in different hosts. Did I answer your question? Yep. Awesome.
So did you face any scaling issues with respect to KDC server? Like, I see the number of requests, like per job or per session, there are 2 or 3 times more the number of requests going to KDC server, right, for TGT?
Yes. See, the way, if you look into it's a very good question, that the KDC could be a bottleneck if you have too many requests coming for the ticket granting service. But one of the advantage on the Kerberos does take is, a lot of times, first of all, it can use the cache. So when you first do a keinit, it generates a ticket, and that ticket is stored in the cache. Now, cache expired, you can configure it, I think 24 hours, 7 days, depending on how you get the Kerberos ticket. So you can cache, so you don't need to communicate. So the first time you get that ticket, you put it in a cache. The next time you are going to talk, you are not going to talk again to the ticket granting service. It is going to take the ticket from the local cache and is going to send it. So that's one of the way to do it. Now, on the other side, where it is getting authenticated, what happens is, it has the service principal and keys, right? So it uses that service principal and keys to authenticate you. So for authentication purpose, it doesn't go every time to the KDC. So that's kind of the trusting mechanism in Kerberos, how it works. So the client gets the ticket from the same KDC server, as well as the server also gets the service principal and the keys from the KDC servers. Because they're coming from the same KDC server, so server can now trust this client and authenticate. But the ticket has an expiration date. But if you don't configure correctly, and Kerberos could be a bottleneck. And there are scenarios we have seen in Hadoop services where Kerberos could be bottleneck.
Just one follow-up question.
Sure.
That will be a quick one. So the Jupyter Hub and the Levy and the client all resides on the same host, or like?
No, they are in a different host, but the Kerberos is a server which is completely running somewhere else. Think of it as your LDAP server. I'm just making an analogy.
I have a two-part question. One is the communication between the Spark Magic and Livy and to HDFS yarn. Are these HTTPS or HTTP? How are you securing the communication?
Okay.
And the second part is, like you mentioned, a separate Docker container is spawned for every session. How do people, can people access each other's session if they want to? How does sharing the sessions work? And how does security for sharing sessions work?
Okay. So let's answer the first question. Now the Jupyter Hub, Livy both support HTTP or HTTPS. It's configurable. You can set it for HTTP and HTTPS. So I think I answered that part of the questions. Now the second part of the question is sharing sessions. We don't want user to share their sessions. Rather, we want user to share their notebooks. Say, when I create a notebook, if I want to share with you, so we are actually, I didn't touch that in these presentations. We added a features in the Jupyter Hub to support for gist. So you can export your notebook to your GitHub repository in the gist format, and you give this gist URL, which is pretty cryptic, and that other user should be able to import your notebook from that Git. So kind of you can think of GitHub is somewhere where you can share the notebooks that you want to share with others. So that's the way we have deployed our notebook setup. Did I answer?
Yeah, just a quick follow-up on the sessions sharing. So you mentioned just that works, but does anyone with the that cryptic URL to the gist can access that notebook, or is that further security?
Okay, now currently we don't, as long as you have access to, because this is our corporate GitHub, so as long as you access to the GitHub, you can access it. But GitHub has its own OAuth authentication, two-phase protocol. You can do a lot of things on that end to kind of stop or allow, but that is not in the context of this Kerberos.
Hi, I'm from PayPal. We use the similar flow, and we too added Kerberos support in the Spark Magic. But I have a small question,
Sure.
More of a clarification. You said KInit is running the Spark Magic in one of the slide. So where actually, the initial KInit, the Kerberos authentication take place? Either it is in Jupyter Hub or it is in Spark Magic.
Okay, let me tell you, there are a couple of authentication points. Like first, the Jupyter Hub needs to authenticate the client. That is happening inside the KDC authenticator. Then Spark Magic does KInit in this case in order to get it authenticated when it is talking to Livy. So Livy actually authenticates Spark Magic as a valid Spark Magic, communicating to Livy, and for that purpose, the Spark Magic is doing the KInit in this case. So they are two different authentication points.
Okay, got it. Thank you.
Just a quick question on the encryption. So you're encrypting the user ID so that you can decrypt it and then do a transplant of that user ID into the session. But the encryption algorithm, what prevents somebody from hijacking another user ID and just encrypting something else and setting that into the environment variable? Given that it's open source, what's the hidden secret that someone can't just hijack whatever user they want?
Okay, so now in our case, what we are doing is the KDC authenticator, or in this case the Docker spawner, is complete control of the admin. User doesn't have access. It's going to use a secret key to encrypt the user ID. Now, during the transmission, somebody can hijack that encrypted text and can inject something else. But if you're going to inject something else, once it is going to be decrypted over there, it's not going to be a valid user ID, right, by the Levy?
Well, it depends on how you're encrypting it.
Yes, exactly. So now the way we support, now the encryption over here is completely configurable. We currently use a 256-bit JWT encryptions, which doesn't only do the encryption, but it is also signed by a PKI infrastructure. So we have a private key that the spawner is signing the user ID, and the Levy is using a public key to also verify the signature. So this is kind of a two-phase guarantee.
Thanks.
So on the Jupyter Hub, you're only doing Espinago auth, and you're not forwarding the credential, the TGT, across the Docker, right?
No.
Okay. Have you considered just getting a delegation token from HDFS and not doing all this transitive trust across so many systems?
Yes, you can do the delegation token. Now, here's the thing, that when you get the delegation token, say you get a delegation token in the KDC authenticator. Now, the KDC authenticator has to talk to Spark Magic to Levy to HDFS. You can actually pass this delegation token, but that is one part. The other part is, say, whenever a party is communicating to Levy has to make sure that I only get or entertain a request from this Spark Magic, not from somebody else. So that is also the second part, which is kind of the authenticating, not the user, but authenticating the endpoints who is communicating to you. Now, the delegation token, of course, you can use instead of KUnit. Yes, you can. And I believe that there is an open source project. If I remember correctly, it's probably from Apple or somebody who kind of, we looked into it, that they provided some kind of open source project through which you can use the delegation token. But honestly, I personally, or we didn't try in our group this delegation token, because there are other issues that you could have.
Okay, for the Jupyter Hub, I'm assuming you're running it under what type of web server?
No, Jupyter Hub, when you install the
it
Jupyter,
comes with
it's a Node.js application.
Oh, it's just okay.
Yes, exactly. Yeah.
Thanks.
So did you explore Apache Knox when you were actually looking at Spark Magic and Livy? There's a couple projects out there already that are actually doing that proxy user rewrite. And what these guys did is essentially just a rewrite rule in Knox to force that proxy user to be written as your authenticated user.
Okay.
Did you explore Knox at all before going down that route of?
Honestly, not yet. If you look into this whole Jupyter Notebook thing, this is probably one way to do things, but that's not the only way to do things. I'm pretty sure there are, like, if you look into even the Zeppelin is another notebook product, right, available in the market. They do it little differently, but your end result is pretty much similar. Now, the reason we use Jupyter, because it's not just to support Spark running in a Hadoop cluster, to do many other kind of analytics activity, because Jupyter is highly extensible and configurable, so that's why we chose. Now, but yes, you are right that there could be many other ways to do it. Okay, so thank you for coming, and have a good day.